Alright, we are working optimization problems. And in this particular problem here, I'm not going to actually state it in words. I've got a nice little picture drawn for you. So what we're going to do is we're going to draw a line through the x and the y axis here, or x and y axis, and we're going to inscribe a rectangle inside the line such that this corner right here um, has a point in common with the line. Alright, so as you can see, A is what we're looking for. I'm calling A on the x-axis, and then the point is AF of A, and this line will be defined as F of A. So we got a nice picture to look at. And of course the idea here is we want to find the rectangle that we can inscribe in here such that it gives us a maximum area. It gives us a maximum area. So if you can imagine the rectangle being drawn here, right, it's going to be a much smaller area than of course the one seen here. Now I just kind of guessed at what it might look like, but anyway, so let me go to the drawing board and let's sketch out some pictures. Of course they're not going to be as nice as this. Alright, so here's the idea. We are going to be given, try to sketch out, do some sketching here, use a different color of course. I think I used red as my line. Right, so we got a line that's passing through here like this, and we want to, I'll make this box inscribed here, and what we want to do is find the rectangle that has the maximum area. Right, so there's a point right here on the line, and of course we called this A, and then this point right here we're calling A F of A. Okay, well, of course this is a more general description, but the actual numbers here, the line is passing through the y-axis where y is 4, and through the x-axis where x is 5. Right? And so therefore we'll call it f of x is equal to, we've got the function here that's going to describe this line, is negative 4/5 x plus 4. So surely you know how to come up with this, right? Find the slope, and then the intercept is y-intercept is 4 here. Alright, so now what we're going to want to do is we need to set up our primary equation. So this is our secondary equation. We want to set up our, this is the equation to our line, is what I meant. And what we're going to want to do here is set up a primary equation that describes the area of this rectangle. So the area is equal to, okay, so this is going to be, right, it's length times width, but we'll call this piece right here the I don't know the length, it doesn't matter, but anyway, this distance is going to be A, and then of course this distance here will be F of A. So A times F of A. So our F is up here, our F of X, and we're just going to plug A in for X here. So this becomes negative 4/5 A plus 4. And that's our area. And of course this is what we want to maximize. So now what we're going to want to do is take the derivative of this, set it equal to 0, and solve for x.